Hello everyone, so I hope everyone is enjoying FOSDEM and welcome to our talk. We are going to talk about challenges in monitoring a distributed storage system and how Tendrl addresses them. So I am Rishabh Jain and I have a co-presenter with me, Gautam, and we are from Red Hat and we are open source enthusiasts. So let's focus on the challenges first. Now everyone in this room might be knowing what software defined storage is, but let me brief it up a bit. Software defined storage is basically an architecture that separates the software from the underlying hardware. And so how many of you have actually worked on a distributed storage system? Great. And how many of you are monitoring or maintaining it? Okay, well, I understand the problems that you face every day. So as you see in the picture, we are going to talk about a distributed storage system. And so there are multiple nodes. Each of them can communicate with each other. Each node has a device attached to it, multiple devices attached to it, and a software that wraps up the complete storage system. And yeah, the client can directly talk to the software. The software provides the necessary resources, and it gives back to the client. So okay, let's talk about monitoring first. So what is monitoring? So in simple words, you can say that monitoring is observing the system and its resources, and maybe finding out, if possible, finding out the exact problem if in case a problem occurs. So the most traditional way to monitor a node is via the CLI commands. So you might have used simple commands like stop or VM stat, and you will be able to find out the CPU utilization as well as rest of the utilization and as well as network related issues. But if you have a single instance, it's pretty easy to monitor the particular node. But right now we are talking about a distributed storage system. So what if you have multiple nodes? Well, in case your cluster has 4 nodes, it's still easier to run command line tools and find out the resource utilization. But what if your number of nodes in the cluster increases? Well, the complexity also increases. Well, and what if your system has 100 nodes? Well, someone is going to get paranoid. Okay, but is this really the best way to monitor a distributed system? So let's consider you are super admin and you find out happy ways to monitor the system. But then are you going to sit in front of the computer 24/7 just to monitor your cluster? Well, I guess not. So this is the big problem that we face in monitoring. But let's discuss another challenge right now. So what happens? So if you have seen the previous architecture diagram, you might have seen that everything was working perfectly. But what if something fails? What if, like, you can see the network has failed or the device is failing? Then an admin will literally go crazy and might have to debug the problem to find a solution. Well, the best way to debug the problem right now or to find out the reason of the failure is through the logs. Thankfully, all SDS provides extensive logging through which one can debug the problem. But then we end up with this, opening multiple nodes, multiple terminals on each node and trying to debug where the problem exactly occurred. And we will end up with this again. So is this really the best way to debug the problem, going through the logs on all the nodes? So the main challenge exactly that we face in a failure scenario is to know why the system failed and where it failed and when did it fail. But going through the logs is not a good solution. So we discussed 3 main challenges. The first one was monitoring multiple nodes simultaneously. The second one was monitoring all the nodes 24/7 and finding out the exact problem in the limited amount of time. So let's see how Tendrl exactly addresses them. But let me brief you a bit about Tendrl. So Tendrl is an open source monitoring tool for cluster, and it provides deep metrics and visualization of clusters. And it supports multiple clusters. But then what is Gluster? Well, Gluster is a Red Hat product. It is the software defined storage for a distributed storage system, and yes, it is open source. Okay.
Yeah, this is the Tendrl architecture. So we split that architecture into 2 different parts. One is the services which are all running in a server side, and the services which are all running in a storage node side. So based on these services, we classified these services into 3 major layers. So the layer which is highlighted in a green is called the storage node layer, and the layer which is highlighted in a blue called middle layer, and the layer which is highlighted in red is called visualization layer. So we will discuss each layer in detail. First, we will discuss about the storage node layer. So storage node layer contains three major services which we are running for monitoring. So first one is node agent. So node agent is the actually an important service. So it will, what the main task of node agent is, it will try to detect whether that node have a cluster file system or what. If it is fine, so it will intimate the cluster detail in, it will push that cluster detail into etcd. And next one, cluster integration service. So this will interact with the cluster using some cluster CLI commands, and it will try to identify that cluster topology, and it will push the details into etcd. So it will try to find the topology with status details, like how many volumes, the volumes are up or down, or bricks are up or down, whether the peer in a cluster is everything is connected or disconnected, something like that. And third is collect D. So this is a monitoring service actually. This will collect the monitoring metrics from the system resources like CPU, memory, and from the cluster. So it will collect all the monitoring metrics, and then it will push the all the monitoring metrics into Graphite. Yeah, we finished with the storage node layer. Now we move to the second one, monitoring layer. So monitoring layer have only one service, then called monitoring integration. So the monitoring integration have a three major responsible. So one is it will upload the monitoring dashboard into Grafana. And second one is it will fetch the cluster topology from etcd, and then it will do some aggregation work, like from these many volumes, how many are up, and from these many breaks, how many are up and how many are down. So these kind of aggregation task, operation it will do, and then it will push those detail into Graphite. And third one is it will try to it will receive the alerts from Grafana, and it will intimate the user via some notifications. Okay, we already finished with the two layers. Now we will discuss about the last layer, visualization layer. So this contains two major parts just for visualizing the metrics and topology. So one is web administration UI, or you can call it as a Tendrl UI, and it will display the cluster topology in a user understandable way. Like using that, user can drill down, and then they can easily identify like how many the volumes and clusters in a the volumes in a cluster, and what are the nodes participating in a cluster. And second one is Grafana dashboard. So we are using Grafana tool for monitoring. So Grafana it will fetch the monitoring metrics from Graphite, and it will display those monitoring details in graph using graph and panels.
Well, let's dig a bit deeper into the visualization layer. And what's the best way to see visualization by seeing apart from seeing graph? So as you can see, this is a cluster dashboard, and we are using a Grafana dashboard. So in this you will you can see the number of hosts and number of bricks or number of volumes that are present in the particular cluster, and you can see the status of the cluster. And so using this dashboard, admin can easily know what all things are working and what all things are not working in the system. So now let's suppose our device fails. So before moving forward, let me explain a bit about cluster topology. So a device is a physical entity, as we all know. But what the cluster does is it formats the device. It places a particular file system on it, and it mounts it. So we call it a brick, and these bricks are used to create volumes. This is how things work in cluster. So now let's get back to that. What if a device fails? So as you can see in the cluster dashboard, you will be able to see that the one of the bricks have stopped, and the volumes and one of the volume that was initially was in the up state has been marked as degraded. But this doesn't give you enough information about which brick failed or where is the brick placed. Let's see host dashboard. In the host dashboard, you can see, so using the host dashboard, you can see which exact host the brick was placed on, which exact host, and that how many bricks have actually failed. But still it doesn't give you the information about when did the brick fail. So let's see the brick dashboard. Now so every time you can drill down a bit deeper so as to find the right solution. So in a brick dashboard, you will be able to see that which host had which brick and at what particular time the brick failed via the graphs. So we were facing three challenges, which was when the system failed, where the system failed, and why the system failed, the popular 3 Ws. Well, let's see how Tendrl solves the problem. So with the perfect drill downs, you are now able to figure out when the system where the system exactly failed, and the graphs get updated every 10 seconds. So so if any change in the graph, if you can figure through the change in the graph, you can figure out the time when the system failed. And using the above information that you just figured, you will be able to find out, you will be able to filter the logs and find out the exact reason of the failure.
Yeah. As Rishabh told, now we have a great dashboard to see the monitoring. Monitoring all the nodes in a cluster. But still, we have to. Are we going to hire an admin to monitor the system 24/7? So the problem still persists. So to solve that problem, Tendrl is Tendrl supports alerting. So any abnormal behavior happen in a cluster, Tendrl automatically detect the problem, and then it will intimate the user via alerts, and also it will send the notification to the user via some notification channels like SMTPs. So actually Tendrl supports two types of alert. One is status alert and one is utilization alert. So status, as I told, status alert is raised from that storage node layers, like particularly that cluster integration service is actually raising the status alert. So status alerts like we saw that in a dashboard, right? So the alerts like brick is down and volume is down, volume is degraded, something like that. So here you can see in the UI, so a few status alerts are raised. And next one is utilization alert. So mostly, the utilization alerts are raised from Grafana. Yeah. Actually, Tendrl will Tendrl automatically figure out that criticality of alerts, and then based on the criticality, it will raise that alerts like warning alerts, critical alerts, something like that. And we will see through demo, and we will see how actually Tendrl is raising the alerts.
So let's see a demo video. Okay, so this is a basic Tendrl UI. This is just one page of it, and over here you can see that we have monitoring one cluster. We have 3 hosts, and there are 0 alerts right now. And this is where there is notifications are displayed. Right now there are only info alerts and no major alerts. So this is the cluster dashboard that we saw. Everything is working fine right now. You can see this is a cluster overview dashboard. Then this is the host dashboard, which gives you information about all the hosts and the bricks, like we saw in the slides as well. And we'll now see brick dashboard. So in the brick dashboard, you will get details about brick. As you can see, there's this capacity utilization, which is 1% for a particular brick. And if I change to another brick, the capacity utilization is 10%. So now let's increase now let's fill some data into the volume and find out what happens when we actually cross a threshold. Okay, I'll just show you via df-h that how much capacity is there. So as you can see on all the 3 nodes, just a minute. I have highlighted on all the 3 nodes. So as you can see, there is only 2% of briquette has been used over there also, and on the 3rd node as well. So now I'm going to put some data into the volume through the fallocate function, and it's just dummy data, and then we'll see how the capacity increases of the volume and whether it's displayed in the dashboard or not. So as you can see on the 3rd node and every other node, the capacity has increased to 86%. And let's check the dashboards now. Well, it's super fast. We got the results in less than 10 seconds, and now you can see in every node that the capacity utilization has increased to 85.5%. Well, and now let's see the Tendrl UI. As you can see, there are warning alerts in the notification mentioning that the brick utilization has on each node has increased to crossed the particular threshold. Okay, now let's so there were 2 alerts, right? So right now we have just we've got warning alerts. Now let's fill more data and try to get critical alerts. So as you can see that data, the percentage of the usage percentage is 96% now, which is above 90%, which was our capacity, which was our critical alert layer. And so as you can see in the dashboards, again it's reflected. And in the Tendrl UI, the warning alerts have been replaced by the critical alerts. So you don't get a new alert. You get the previous alert gets updated, and you can see in the alerts section. It's also mentioning the number of alerts there are in this particular cluster. Now let's remove the data and see if the system can recover and show that show whether the alert basically remove the alerts or not. So I'm removing all the data from all the 3 nodes. As you can see, the capacity utilization dashboard has been back to normal, and over here from the critical alerts, they have become information alerts that there was a critical scenario, but now it has been solved. Well, okay. So that's all from our side. Any questions? Go ahead.
You mentioned something about log messages and how to parse them, but this just seems to be more monitoring related. So, am I confusing what you mean about logs? So it's not about syslog stuff.
No, logs in the sense of what the. Sorry. Okay. Yeah. The question was that am I mentioning about syslogs or am I just mentioning about the logs of the particular SDS, right? So I'm mentioning the logs. So Gluster is an SDS, which is a software defined storage, and it logs its messages on each node, right? So I'm talking about those logs. So I did mention that every SDS has extensive logging capabilities, but if I want to find a solution, then I have to go to every node and find check the logs to find the reason of failure. Is that good enough? Does that answer the question?
You're not aggregating the logs in some way, parsing.
No. What I'm doing is I'm giving you the exact node where the problem has occurred, so you can pinpoint you can go to the node and check the logs.
It's something like you look at what time it failed, and then the time you capture the time and look into log. Around that time frame you find the exact issue.
Yeah, it's basically useful for filtering the logs. That's all. Shoot. Yeah.
My question is partly answered by now. My original question is that if you collect the logs and then you push it to etcd, or you just register the timestamp of the event. In that case, why could you use the RSys log, for example, just forward directly to the database?
No, we don't do that. We don't push the logs to HCD. Okay, yeah, sorry. So his question was that why, if you're pushing the logs to the HCD, then why do not use RSys log, right? Yeah, we don't push the log. So basically, this tool is made for Gluster, which logs it on different nodes, each node. It's so if a SDS is logging on particular centralized database, then I guess it makes more sense of using something like RSys.
For example, within a brick, let's say a replicated brick, you will affect, I don't know, 3-4 different hosts. Will you go on every different host to get the logs from there? Sometimes.
No, so I'm sorry. I think okay. The question was again that.
The question is, if you have multiple nodes affected by a single operation on the brick, let's say on the replication, so you have one write, and this write goes to 4 or 5 different devices. So you log in at one time to every different node and do the log analysis there.
So the question was that if a particular failure occurs on multiple nodes, then will the software do log analysis on each node, right? So Tendrl is a monitoring tool as such, and it doesn't do any log analysis. Log analysis is something that means finding out the reason of the failure is manually only. We don't provide any such feature. What we do is we will give you the exact the place where the thing has the failure occurred, the time, so that you can filter log by yourself by maybe using some other tools like or some log aggregation tools or like Kibana or things.
And to add to that, actually, Gluster is supporting Gluster event. So to add to that, actually, Gluster is supporting Gluster event. So anything affected in multiple nodes, the Gluster events is actually raised from all the nodes actually. So what Tendrl will do, Tendrl capture that alert and then it will highlight to the user actually. So then user can easily see that.
So so these are events that Tendrl displays. So that event will be displayed over here.
So kind of history it will maintain actually. So you can track it.
Any other question?
Can I manage my cluster with Tendrl as well? So to be more specific, can I create bricks, queue replication, or any nodes?
No, actually Tendrl is only for. Okay. The question is like we can. Actually, the question is like can we manage the cluster or what? Like create brick and something like that. So actually Tendrl is only for monitoring. It's not for doing any creation things.
It's a monitoring tool instead of a managing tool right now. Yeah, shoot.
I'd like to know which kind of data backend you use for the Grafana. So do you use Prometheus or Graphite? What's the backend?
So
Graphite. So time series.
Yeah,
Okay.
I was doing that. So the question was which backend, basically database, do you use for Grafana? And we use Graphite. So we stored the data from Gluster to Graphite, and then we display it using. Yeah, shoot.
What about like regular system monitoring, CPU health, and RAM utilization, so on? So you have to have different monitoring tools, I'm assuming. So is there any way of like making this send the data to another monitoring tool or something like that?
So the question was that can we send data from the data that has been collected by Tendrl, send data to some other monitoring tool? So no, we provide a complete package as such from backend to the front end, and this package can be you can monitor everything in Grafana properly in one dashboard, or like as you can see drill terms, but you cannot use those data. Or if you get, like we push the data to Graphite. If you want to use the data from Graphite, you can. It's an open source tool, so you can.
So Graphite has a web interface. Okay, it provides REST API. So
Yeah. So you can pull most of the data from Graphite, and then you can use it for your personal use or monitoring purposes. But as such, this kind of integration is not provided by Tendrl.
Okay, thanks guys. Time is up unfortunately.